All right, good morning, everyone. We're going to get started this morning. We're grateful to have you all with us this morning to talk about RLE and higher education, how our products are used as solutions for colleges and universities. So we have four presenters with us this morning. We have Tom Metzinger and Jen Beliveau from RLE. Tom is our Vice President of Sales. He has more than 24 years of experience in sales and sales management. And Jen Beliveau is our Business Development Manager. She has more than 20 years of experience working in the data center, mission critical, HVAC, built environment, and banking industries. And Jen has extensive experience in the IT and data center industry that she leverages to help craft the right solutions for each unique facility that she works with. Additionally, we are glad to have Raymond Parpart, the Director for Data Center Strategies and Operations at the University of Chicago with us this morning. Ray is responsible for the university mission-critical data center facilities. He partners and works closely with stakeholders to ensure reliability 24/7 to data centers across campus. He delivers expertise to the campus community, and that crosses platforms into system and facility design, operational support, and government compliance in a variety of areas. And he also assists in the constant improvement of system hosting, colo services, and energy efficiency in these complex computing environments. Jay Harris is also with us today. He's the Director of Data Center Services and Facilities at Clemson University. He's been a part of Clemson's CCIT group since 2009. He is responsible for the university oversight and daily operations of 2 data center facilities. You can see from his credentials and from the description of his facilities here that he oversees a lot of space with a lot of complex computing needs and computing difficulties that he works with every day. Reliability based on the services that operate out of his data centers are critical on his campus, as they are on every campus. And he also directs the enterprise print facility.
Thanks, Jenny. Good morning. My name is Tom Metzinger, and today Jen and I are going to discuss how RLE's product lines work together to provide universities a complete monitoring solution. Then we'll hand it over to Ray to discuss deploying RLE products into existing spaces without retrofitting the facilities. And afterward, Jay will discuss how he has improved oversight and efficiencies at his university. So, at RLE, we think your solution should fit your facility and not the other way around. Our wired and wireless monitoring are very flexible and vendor and integration neutral. So we tailor the solution to fit your application. Our FMS system is comprehensive to monitor sensitive facilities, critical equipment, temperature, and environmental sensors. It's very feature rich and affordable, and it's used in data centers, labs, telecom facilities, museums, universities, and other types of facilities worldwide. It stores all its own data and hosts its web pages, so you don't need additional servers or software to use it. It has good onboard features for trending and logging. It has interactive mapping for facilities. It has nesting, which Jim will get into, to allow one FMS system to report on the conditions of others. It monitors several different types of sensors, and basically, devices that can give you dry contact, 4 to 20 milliamp, 0 to 5 volt DC, and 0 to 10 DC outputs. So things like temperature, sensors, water, humidity, voltage, amps, airflow, smoke, gas, motion, doors, lights, sounds, just to name some of the different things that it can pull in. Also, it supports the following protocols: SNMP, Modbus, BACnet. So existing types of equipment that you could pull in and monitor would be computer room ACs, PDUs, power meters, UPSs, branch circuit monitors, transfer switches, IP cameras, generators, panels, and different types of security systems. It's vendor neutral, so it aggregates all types of wired and wireless sensors and then displays them on the onboard interface. And if you have a building management system, that's fine. The FMS can grab all that data and push it into other systems without any additional hardware or software. Firmware updates are free and available on our website to keep your device up to date, and no recurring subscription fees. So you buy it, you own it. With that, I'm going to hand it over to Jen. Hey, Jen.
Good morning, everyone. All right. Good morning, everyone. Thank you, Tom. Here you see what we refer to as a campus nest map, which can display up to 32 integrated FMS products. RLE's facility monitoring system, or what we refer to as FMS, is a comprehensive monitoring system commonly used to monitor sensitive facilities, critical equipment status and temperature, and environmental sensors. Each dot, or egg, represents an integrated FMS product, such as our F200, which is a wired product coupling leak detection and facilities monitoring, which is ideal for campus network closets and small MDF and IDF rooms. We have an LD2100, which is a distance read leak detection controller that monitors up to 5,000 feet of sensing cable or spot detectors or a combination of both in any built environment to protect your facility against water damage. We have our Wing, which is our wireless network gateway, including a wide variety of wireless and Wi-Fi sensors. And lastly, we show an LDRA6, which can serve as either a 6-zone leak detection controller or a remote alarm annunciator. The color identifies the summary status of the alarm of the integrated products throughout the campus. The dots, or eggs, also contain links that'll take you to the specific FMS product. The Delta Map view of the FMS is patented and standard with the FMS. It also allows an image to be used as a background image and provides graphical representation of the current status of sensors and equipment throughout the campus. This Delta View map that you see is accessible from any device, such as a cell phone, a tablet, it could be a laptop, etc., that can connect to the network via a web browser. So Tom, next slide, please. Now let's take a closer look at a dot or an egg product's alarm status. By clicking on a dot in the Delta View Nest image, as we showed you on the previous slide, you'll be taken to the RLE product at that location. This egg map status displays more detailed information. The Nest map link will turn red if an egg is in alarm state. We can see there are leak, motion, temperature, and door alarms that need to be addressed. In addition to being able to see where the alarms are occurring through the Delta View map, you can also be informed of alarms via email or text notification, as well as by the sounding of audible alarms of certain RLE products. And as Tom mentioned before, our products integrate via Modbus, BACnet, and SNMP communication protocols to an existing building automation or network management system to give you instant notification of any alarm occurring in your facility. Back to you, Tom.
Thank you, Jen. So, in addition to data centers and communication closets, universities have other areas to monitor. In February, a massive freeze hit the South, and one university had to actually check every dorm room for leaks or bursted pipes. So in the picture above, you can imagine with the addition of a spot detector or sensing cables, you could give the facility team visibility into these spaces. And more important than that, you'd get the notification immediately instead of waiting until you find the right dorm room that's leaking and prevent a much more extensive damage. So we have several types of controllers that could aggregate all those different points and then deliver them to a building management system. Jim, when I was in college, I also really loved the meal pass at the cafeteria, all you can eat. So, the picture on the right shows another monitoring area. All the good food that they cook every day for the students needs to be stored in a freezer before it's prepared. So a failure in cooling could spoil thousands of dollars worth of food, leave the school with a lot of hungry students. And if it was pizza day, who knows what could happen? You could have pandemonium. So with the use of a sensor like RLE's Wing Therm, you have the ability to put a temperature sensor or a thermistor in the environment that wouldn't be friendly to wireless transmission, like a cafeteria freezer, while keeping the transmitter portion of the sensor outside that environment, sending back readings to the wing manager or BMS wing. Those data points could then be shared with, whatever central management system the university was using. At my university, Oklahoma State, go Cowboys, go Pokes, there's been, it's a 100-year-old university. There's a mix of old and new buildings. As enrollment increased over the century and new fields of study were added, or T. Boone, built new facilities, you'd have a big mix of new and existing spaces. So now it's my privilege to turn it over to Ray to talk about deployments in, existing spaces inside the university. Thanks.
Thanks, Tom. Good morning, everybody. So we're at the University of Chicago here in Chicago, Illinois. So we're quite familiar with deep freezes, but I think we're a little more prepared to handle them. So we were faced about a year ago with retrofitting and monitoring some legacy crack units that had no intelligence in them. We do monitor at the cabinet level and some other things, but we really were trying to figure out a way to monitor crack units due to failures and temperatures and power, a whole bunch of unrelated issues. But so the first thing, just to give a quick background of who I am and what we do, is one of the things I like to do in the data centers is monitor everything. Literally, I want to monitor it all. I want to know what's going on at any time, in any space, with all the stuff that's starting with utility power coming in, generators, distribution, ATSs, all the way down to the cabinet machine level. So we monitor all our HVAC systems through our building automation system, and rely on campus. And we're looking at stuff all over the place, not only just in the data centers. Try to stay to two systems. We're down to our DSIM and a building automation system. So everything we do, we want to talk to our D system. So back to our monitoring. We're looking at some crack units. Some of our crack units are 20 years old. They just keep working, so why replace them? But they have no electronics in them. And so working with RLE, one of the things they suggested was their new wireless system. And I am not a fan of wireless, as my team will tell you. I fight it every chance I can. But the space we put it in that you see is relatively small, and it's manned 24/7. So I thought, if anything, this would be a great opportunity to test wireless. And so we put it in. We put sensors on all our crack units. So we not only, as I back up, one of the things I'm trying to look at is, are things running? Are they not running? What are the temperatures? What are the humidities? So we put temp humidity sensors before and after in the airstream. So entering air, leaving air. We've got differential air pressure sensors on all the units. And the reason for that is to understand if the filters need to be changed. If the differential pressure is not changing, then why change the filters? We do it to keep people out of the data center, but we also do it to save money. It's a few bucks, but it helps. We check air velocity because this way tells me if the units are running. We've had a couple power outages where we've actually lost crack units. And so we want to monitor the air flow to track both in a lead lag, but also if they're running. And we do track temp, humidity, airflow, everything in all these systems tie back to our DSIM. We're currently using the Wing Manager. Again, I'm not a big fan of wireless, but it's proven very beneficial in this environment. During some of our cooling events, we've learned that we can actually grab sensors because they're magnetic and put them anywhere we need. So as a result of a couple issues 2 years ago, we now have an emergency cooling model in this data center where we actually bring in fans and temp cooling units. But when these things happen, we can literally grab air sensors and flow sensors and temp sensors off the existing crack units and put them anywhere we want. So in our cold aisles and our hot aisles, so we can understand what's going on. So not only being wireless has been beneficial, so I have to admit I'm enjoying the wireless environment, but we're able to track everything. And everything we do goes into our DSIM, and so we've tried to get to a single pane of glass and keeping tracks and trends of everything. And the trending is what really helps us too. So that compared to our power usage gives us some really good information. We do use the RLE leak system. We're now literally today, when one of our, in the space that you're seeing on the slide is being upgraded to the RLE leak. Ironically, the electrician showed up today, started running the rope. We're replacing an older system that just failed. But what I like about the RLE is, as pointed out earlier by Jen, is the map and being able to have a foot marker. So when a silly thing goes off, and they do go off, things happen. We're not trying to just go, hey, there's a leak. We can actually look at the map and go find exactly where it is. So we've come to depend on the system. It's been very beneficial to us. And the implementation has probably been the best effort that we've had. We've started now to expand not only into the data centers, but into our critical comm closets across campus. And we can actually set those up now in about 30 minutes because you pre-config all the sensors in a Wing Manager, take it out, drop it in, get it on the network, stick a couple sensors in literally with magnets and off to the races. So we're now putting this in our critical closets across campus to keep track of what they're doing. So that's about all I have today. So Tom, I'll give it back to you.
Okay, hey, thank you very much. Next up. So Jay, the floor is yours.
Well, that's a tough act to follow there, but I'll try. And if I don't do well, it is April 1st, so that's y'all's problem there. My data center, I often get asked to talk on these things because I'm trying to treat a dinosaur. This data center was built in 1987. So I'm 33 years old. As you can see from the double diamond shape there, the architect was more interested in pretty than functional. And if you can look at the production and co-location room and see all of the jut outs there, you can see I have a lot of stranded areas that are very difficult to get airflow to. That production and co-location room is 9,200 square feet. So that is a huge area, and the way things are designed, the airflow is not optimal, especially off to the right-hand side at the bottom, which is where my network cabinets live. So a couple of the products that I've used and have found helpful for me, we've been buying the Triad floor panels for a while, and those work very well because it's very nice to have a vented floor tile that you can grab up with the handles and not have to have a tool. So that makes it very simple if we need to move one of those around. I also have been using the hot spotter fan trays. So in that lower right-hand corner, I've been able to use a hot spotter fan tray underneath the floor. And instead of the 220, 230 cubic feet per minute, I can get 1,100 cubic feet per minute pulled over into that corner. So that has been helpful for me in some of these odd situations. The HPC room off to the left is only about 5,200 square feet, but just as the room on the right, it only has 200 tons of cooling. So if anybody's scratching their head and doing the math real fast, 800 kilowatts of load and 200 tons of cooling does not work out very well. So we have, on the left-hand side, they've grown over time, and there's just, it's a bad situation. There's some concrete near the restrooms there at the top of the HPC room, so I'm having trouble getting another crack unit in. We've gone to cold aisle containment many years ago. I'm actually using some of the hot spotters in the cold aisle containment because I'm having to pull even more airflow in. So that led to the next problem we have as we get densities, densities in the 3, 4, 5 kilowatt per cabinet on the production side was nothing. That's not a big problem for me. The HPC side have densities that were running, 7, 8, 9, 10, 11. Then GPUs came onto the scene. And once GPUs dropped into my high performance cluster, we were averaging about 16 kW per rack on any given day and could easily burst up to 20, 22. And that makes it very difficult. So we actually went to rear door heat exchangers, which as much as Ray said he resists wireless, I don't like water underneath the raised floor, especially when you stop and consider right about where the letter C is in HPC is where my UPSs live down in the basement. Did I mention this is a 33-year-old building? Does anyone know what concrete does after 33 years? And what happens when water finds those tiny little cracks? It goes down. Gravity does work. So we are using the RLE, I think it's the Falcon 200, using that as with the rope leak sensors to identify any leaks early so that we can get things valved off there. Luckily, and I'm going to knock on my head here, luckily I haven't had any leaks of that system, but I wanted to get that in ahead of time. So I've been using a number of those different sensors. I also have been fortunate enough, I guess is the right word, that we drained a UPS to the point that the battery breaker tripped. When we got everything back online, put a hard charge on batteries that were, down to 50% load, they popped a couple of coin cells, generated some hydrogen in my battery room downstairs. So sitting in a box here behind me in my office and not yet deployed, I've got another Falcon 200 that I'm going to use with hydrogen sensors to give me a little bit more early warning down in the battery room for my UPSs. So what I've wound up with here is a 33-year-old facility, 34, coming up on 34-year-old facility that was not well designed. It was probably designed well in 1987, but as densities have increased, I've had to start retrofitting and looking for the tools that will give me better insight. So I think Ray is a little bit ahead of me in monitoring everything. I want to monitor everything, but I'm a facilities guy trapped inside of the IT department. I'm the redheaded stepchild of IT. And as I go to the table with my hand out for sensors for this and sensors for that, there's 3 or 4 people across the table holding their hand out for software and hardware. And the IT group goes, we really ought to spend our money on software and hardware. So I'm not quite where I want to be, not quite as far as Ray is on monitoring everything. I've got goals, but it takes a while to get the funding for that. But some of the RLE between the hot spotter fan trays, the triad floor panels, and then the Falcon 200 series for leak detection, as well as the one I'm about to install for hydrogen detection. Some of these tools has helped me retrofit an older facility and get a better view and earlier warning system than what I was able to do before. They do fit in very well with my building automation system, and as well as just using SNMP. So it's, again, your mileage may vary, but on an older facility that is very poorly shaped, they've given me a good insight into what's going on and helped me figure out how to better utilize what I do have. And I think that's about my spiel. If anyone has any questions for me, I'll be more than happy to answer those when we get to that section.
And we're there. Thank you, Jay.
Thank you, Jay, Ray, Jen, and Tom. We appreciate you this morning. Everyone, if you have questions, you can feel free to drop them in the chat and I will ask them on your behalf. You can send them in the chat to everyone, or you can send them directly to RLE if you don't want to put them in the public chat. That's totally reasonable. We do have a couple questions already queued up. So while you're typing, I will start asking some of the questions I've received already. The first one I have is for Ray. So Ray, you mentioned that you're not a wireless fan. What are your concerns about wireless, and why has RLE's wireless system helped you overcome some of these concerns?
Biggest issue I have with wireless is someday I got to change the batteries, and now I got to go find them. We just put up a building that every sensor in the building is wireless. There's over 3,000 sensors in the building. That's my biggest concern. In a small environment where we are, I think the wireless is going to work. And I may change with lithium technology and the batteries getting, are we going to get the 5 and 10 years out of them? We'll see. In a little environment like this, I'm okay with it. But even in my house, I'm not on a wireless connection. I'm on a wired connection. I'm old, I'm fat, I'm bald. I want things to work. And I know when I plug in a wire, it's going to work. So, but that said, I'm bending to being more tactical and strategic with where we use wired and wireless. So I'm coming over to the dark side a little bit.
Thank you, Ray. Again, for either Jay or Ray, so through the decision-making process, how did you decide on RLE as the option that you chose for monitoring within your campuses?
Go ahead, Jay, I'll let you.
I looked around, I did some comparisons. One of the things I liked was, the multiple protocols that I could connect via SNMP as well as Modbus. So in looking around and seeing what other people had done and just comparing the specs, it seemed to work well for me, and it fit the price point that I needed. I also liked the no internal components, or as he corrected, the no moving internal components, hard drives or things like that. The fact that I own them and can get all the updates for free. Several other people wanted me to, pay a subscription fee, pay a renewal every 3 years or something, and that turns me off very quickly right there. If something's 5, 6, 7 years old, I don't want to keep paying for it.
Yeah, we're in the same boat. We needed the capabilities and looked around, tried a couple different units, some of the competitor units, and it came down to price and function. Prices were close. RLE was a little better, but it really came down to function and capability. I think the breadth of the product line that's continuing to grow, to me, is critical. I mean, some of the DSIM softwares you look at, same thing, you kind of get stuck in them and they're really not expanding. So I wanted to do so much in continuing to add on. Eventually, we're going to add CTs and we're going to add hydrogen sensors. So I think there's value in the fact that the product line is growing and it all integrates cleanly.
Excellent. Thank you both. This question looks like a toss-up for both of you as well. So how user-friendly are the products you installed? Thinking about like average users, amount of technical knowledge and time and all those things on a global issue.
Well, the person who set this up for us is on the phone, Alex Lee, and he was new to our organization, and I said, here, go figure out how to make this work. 2 days later, he came back and said, okay, where do you want it installed? We found it extremely user-friendly and surprisingly easy. Now, if you're getting into the more technical things of Modbus and BACnet and registries and things like that, but to take the wing manager, the RLE, the wing managers, the sensors, plugging this stuff together, it's borderline plug and play, turn it on and it works.
We had the exact same experience. The first one we bought was the rope leak sensor. I was sitting with one of my new employees in the canteen, and about 12 minutes after we turned the thing on, we threw a wet paper towel over it and it started beeping at us. So it was very simple and straightforward.
Sorry, on a side note, that's how I found RLE. A couple of years ago, I had a leak go off in my data center at like 5:30 on a Friday when I was halfway home. And all you get is, it's a leak. And I went back, found the leak, got online, found a system that would tell me what foot marker the leak is at, and promptly ordered it the following Monday and put it in. So.
That's awesome to hear. When I think about the efforts that our engineering team goes through and developing and creating these products. It's great to hear that the things that are important to you are the things we're definitely addressing in the development of our products. Have either of you had an instance yet where either of your systems notified you of a change in condition or an issue before it became a serious issue or before you would have seen it on your own?
I'm going to go ahead and say I've only had the leak detector for about a year now. So again, I'll knock on my head here. So far, no, I haven't had it report anything that would be a problem, but that's exactly why I put it in. And we have tested it once or twice. Like I say, we'll throw a damp paper towel over the sensor and it reacts extremely quickly. So I'm hoping that it's one of those beautiful things that I bought and never bothers me, but I'm pretty sure it will when I need it.
So we've actually had events where the systems have warned us. We did have a leak in I'm in 100-year, one of my data centers that's not listed here. The one that's in the picture was put up in 89, so you beat me. But it is an old building, and you're right, you have all kinds of stuff. We have a data center, another building that's in a 130-year-old building. And we had our leak detection system go off. Unfortunately, at the time, it got ignored. And a day later, the next day, we lost a UPS. I actually had water, like you said, pointed out, Jay, went through a crack, found a 100-year-old conduit, traveled through the conduit, came out a 1900 box, poured into the ceiling, dropped on a piece of unistrut, rolled over about 3 foot, and then dripped on a 600-volt DC bus and a UPS and blew it up, literally. I could still have the piece of equipment with all the big burn marks. The UPS survived. Surprisingly, the UPS did what it's supposed to do, but we wound up with an overvoltage, overcurrent, undervoltage, and tripped the room. That's a different story. But had somebody paid attention to the leak detection, the problem would have been, we would have never had the issue. So we now respond to alarms. We do get temp alarms when things are getting a little warm, high head pressure on a crack unit. So we now get those alarms. We can go investigate instead of have to physically walk through the room every hour. So again, some of our crack units are 30 years old. They just get dirty. So indeed, we do monitor and they do help us. So yes.
And Ray, we have a follow-up on that one. So you mentioned that the alarm was ignored. Why was the alarm ignored? Was it because you had mentioned your previous system had a lot of false alarms? Was that part of the reason why the alarm was ignored in the first place?
No, well, not whatsoever. It was the human factor that got in the way. So there was a change in leadership, and the team that normally would have responded to it was directed that their jobs had changed. And so it just simply got overlooked. It was pure human involvement. It happens.
Which might be one of the things our products cannot fix, but maybe we can put that in the next rev. So a question that might be a little more directed to the RLE staff here, but maybe you two can answer based on your experience. Colleges and universities just traditionally have an immense number of older buildings on their campus that are retrofitted for other purposes. So can someone, I don't know if who this one is best suited for, but talk a little bit about leak detection and RLE products in older buildings and maybe what some of that notification process looks like across an enterprise.
I don't mind taking that or checking to it. So I've got a communication room that has a crack unit that literally sits above the president of the university's office. And I'm not exaggerating. And it leaked one day. Fortunately, when it was leaking, we were in the room. So we now have RLE leak detection around this unit for that reason. We actually had a chilled water line break in one of our buildings, and the data center leak detection system caught it. It was a fairly large issue. We used a central chill plant, and one of the buildings on that central chill plant loop blew a line. There's 3 foot of water in the mechanical room and 6 inches of water in the database in the data center. And facilities found it because our alarm was going off and they monitor our alarms. So we've been working with facilities in our automation system for campus to share alarms. We monitor a lot of facilities spaces now with these and other products, and we're now expanding this product line into, again, like I said, comm closets, mission critical rooms, mechanical rooms, and mechanical rooms that could impact critical spaces. And so the alarms are now shared through our operations center and our monitoring tools in emails, both to our facility staff and our mission critical staff. Hope that answered.
Yeah, I think that was great. Thank you, Ray. I appreciate it. I believe that is the end of the list of submitted questions I have. If anybody else has any, we still have a few minutes available in our time slot here on our webinar. If not, I want to thank you all for joining us this morning. Our contact information is there on the screen, and you can reach out to us anytime via phone or email. If you have any questions, this webinar has been recorded, so it will be posted on our website, so you can come back and reference it at any time, or if you would like to share it with anyone else, please do. And we are also inviting you to join our next webinar, which will be on April 29th. We're going to talk about healthier indoor spaces. That will be an introduction for a new wing sensor that actually went up on our website this week, available for pre-order. It's a wing CO2 sensor. So if you need to monitor, it monitors carbon dioxide, temperature, and humidity. So if you need to monitor any of those conditions in your spaces, that sensor is available now for pre-order. I would encourage you, if you think you will be looking for those, to get your order in sooner rather than later. I'm sure you all know, with the increase in CO2 monitoring across pretty much globally right now due to COVID, those sensors are a little scarce at times, and we want to make sure that we get all of our engaged customers in line for that sensor first and foremost. So let us know if you're interested in that. I have so much gratitude towards Jay and Ray for joining us this morning. Your insight and your experiences are invaluable for customers in this field who are trying to visualize how our monitoring would work in an existing space they have. And we are really impressed with your applications of our products and your knowledge in monitoring, and really the complex environments that you monitor due to the age of your facilities and the size and scope of your campus and that community is really a testament to the hard work you do and the effectiveness of the products, and we're grateful that we can help you out. So thank you to our presenters. Thank you to all of our guests. It was great to have you here this morning. We hope you have a great day.